Here we go. Today, day 2. Tomorrow we start the 6-day lab. It's the second of 2 very important days. First thing I need to mention, safety. This lab is rather unique from other labs we've done throughout the year. Let me tell you why. Yes, safety was important all throughout the year. We tried to practice good safety habits. Goggles, aprons tied up, and hair tied back, for obvious reasons. This lab is especially important because previous labs, there may have been a point during the lab where everybody was doing the same lab, the same time, and pouring acid at the same time, or something significant that could have been dangerous. Okay? More dangerous than usual, just being in the lab. At that point, I may have yelled at you and said, get your goggles on, your aprons, and so on. It was critical during that little period. This lab's a little different. From bell to bell, we've got 20-some people in here doing 20 different things. Yes, some of the chemicals are kind of nasty. Not any worse than the ones we've used all year. But 20 different people doing 20 different things at the same time and the same space can be a problem. So A, work carefully. Be aware of others around you. And number 2, when you come in, the bell rings, you've got your goggles over your eyes, you got your apron tied up, and you got your hair tied back. Okay? No exceptions. When the bell rings, you take them off. It's very, very important to do this. If I catch you without one of those 3 things, you sit down for the day, you miss that time of your 6-day lab, you just sit and think about it until the next day. The reason why we have to be very precautious here, last year we had an accident. It wasn't in my room, but it was during the unknown lab, and it was the definition of an accident. One person asked to have a reagent handed to them. Could you hand me that? Sure. Pick it up, slipped as they're handing it, comes down, hits the table, glass goes flying, happened to be a very concentrated acid, and that 1 in a million chance that a drop of the acid went straight into the person's eye. Very nasty situation. That person was not wearing safety goggles, and it could have been very severe. Okay? Had goggles been on, wouldn't have been a problem at all. That's the purpose of the safety goggles. Nobody plans an accident, but that is an excellent example of the definition of an accident. It's a 1 in a million chance, but you got to be prepared, and your eyesight is obviously very important to everybody. So make sure goggles are to be worn at all times over your eyes. Aprons tied up, hair tied back. Okay? Okay, today we want to look more at how we go about identifying ions in the actual procedure. Let's start here on your instruction sheets. Make sure you read through this stuff by tomorrow, again. Especially the hints down here on page 1. Many of those things you'll find will be useful if you remember where they are. If you get stuck sometime in the later pages, come back and visit this section. That might be why you're stuck. Let's turn to page 2. PPT stands for precipitate. On page 2, if you notice, out on the lab stations now, we got lots of test tube racks, 2 for each table, and they're filled with test tubes. I borrowed the first one, that's why there isn't one there. Now these are in addition to the ones that are locked up in your drawer. So when you get those out, there should be up to 4 test tube racks with 4 sets of test tubes. Plenty for everybody. One precaution, 6 periods a day are going to use the ones that are sitting out right now. So do not, I repeat, do not lock up those test tubes that you see out here. Those are for everybody to use. The only thing that should be in your drawer are the 4 that are issued in your lab kits that are locked up in your drawer. If we have to, we're going to get out the master key.
Please excuse the interruption. At this time, please dismiss freshmen who are in Mr. Potter's homeroom, that's Reynolds through Scott, to go to arena scheduling. Again, that's freshmen in Mr. Potter's homeroom, Reynolds through Scott, to report to arena scheduling. Other freshmen that were scheduled for arena scheduling today will be scheduled tomorrow. Thank you.
If we need to, we'll get the master key out, we'll go through the drawers, and there may be deductions for people that are hoarding test tubes. So don't let me catch you with more than 4 test tubes in your drawer, okay? Share the ones that are out. Okay, you stake your claim to about 4 test tubes in a rack, and we'll just walk over here to the sink because we're ready to wash these things. Remember, all the glassware should be washed with Alkanox, very concentrated soap. You don't need very much. I put a little bit in here this morning, and I probably got about 3 weeks worth of glassware in here. So it doesn't take much. Once you get some on your test tube brush, you probably don't need to put any more on the rest of the day, perhaps the next day too, okay? So keep that in mind. Here we go. I got 4 test tubes here that I want to wash, and of course they're always dirty. Assume that everything's always dirty because you got no idea what was in it before, okay? So we're going to turn the water on here, slowly, remember. Sometimes the water comes out at high pressures. Rinse those out, put a little water in them, and we're ready with the test tube brush. Notice I got 4 in my hand. 1, 2, 3, 4. Look at all that soapy substance. Notice one thing I did not do is stick it in the bottom and grind and grind and grind. This is metal. I've seen it pop right out the other end because people are grinding it through the test tube. Don't do it, okay? I'm done with that. I set it aside. I still got lots of soap for next time, okay? Got to rinse this out. Tap water's okay for that. And I just need to do this several times because it's very soapy. Always start with about 4 clean test tubes.
You either rinse down with the tap water.
I'll show you. When you got all the soap out of there, off the outside too, okay, that looks pretty good. I got 4 clean test tubes, except for one thing. Since on all my unknowns are ions, why don't I want tap water in here? Yeah, there could be ions in the tap water, okay? So we want to avoid any complications. I want to do a good job. So I'm going to rinse these out before I use them with distilled water. So you just take the distilled water, add about 1/2 inch in the bottom, and watch how you do this. You turn it and tilt it, turn it, tilt it, turn it, tilt it, until it coats the entire inside edge, and then it comes out. You've replaced all the water on the inside now with distilled water. It's okay that it's wet because we're going to be adding more. So there's one. We'll do this to the others real quickly, and I'm ready to go. And you can see here, even with talking and doing other things at the same time, it didn't take me that long to clean. Do 4 at a time, I'd recommend, so you don't have to stop all the time and just clean 1 test tube. There should be plenty of test tubes. Okay, now I got 4 clean test tubes at this end. I'm going to say, okay, this is my spot. I'm going to use that end of the test tube wrap. Okay, I'm ready to go. I got clean glassware. On to the beginning. It says to make original solution. This is where you'll always start. It says 1 metal scoop of your salt and a 1/2 test tube of distilled water. So I get my salt out here. I borrowed this from one of the kits. Not yours, of course. And I'm going to use my scrupula or spatula here. Spatula actually this time. It actually fits inside there, and I'm just going to get my salt on the end of this. Take some of that into one of my newly cleaned test tubes, and in it goes. Now the sides of the test tube are wet, it sticks to it, that's okay, because I'm going to add distilled water anyway. Naturally I'm going to add it so it squirts down all the sides. Okay? It says half filled test tube. About halfway. Original solution. Next, remember the 3 things you can do to increase the rate of dissolving? I'm doing one of them right now.
Mixing.
Agitating, right?
Yes.
Proper way to agitate. Look at this. Hold it tightly between your thumb and first finger up at the top and hit it kind of hard down at the bottom. It should kind of flick. And if you're up here close, you'll actually see a little If you just sit there and hold it kind of loose and do this, and people tell me, yeah, I've been mixing that for 2 days, can't get it to dissolve. Doesn't do anything. You got to do it the correct way. You got to really hit that thing and get the stuff up off the bottom. Okay? Get it to dissolve. If you need to. Remember, the second thing you can do is heat will help things dissolve. So heat up over the burner, keep agitating for another couple minutes. Heat it up a little bit, not too much, keep agitating. Okay? Everybody get the idea. After a few minutes, it should dissolve. Now, I happen to pick one of the lucky ones. Still looks kind of cloudy. It could be that it's just saturated. It's not going to dissolve anymore. Here's what you can do. Two choices, and it says there. One, you can get your filter paper out and filter it using a funnel like we've done before in the lab. Place a clean test tube underneath the funnel so you can catch the filtrate as it comes off, and you're ready to begin. You can also, after you've mixed this for several minutes, if it looks like the particles are going to settle out quickly, you can simply let them settle and pour off the clear solution off the top, because it should be saturated, it should be ready to go. Okay? So those are your choices. Most of them, however, are going to dissolve quite easily. Some won't. Okay. Now, one thing I like to do is always place my original solution in the same spot, so I always know where it's at, right in the corner of the test tube rack. Okay? Question?
You want your original solution to be clear or cloudy?
You want it to be as clear as possible. And that's why I said if it does come out cloudy, you may want to filter it,
Is that a little too?
or you may let it sit and pour off the top. Yes, this one I'd recommend to do one of those two. Just happens to be the one I picked. Most of them come out pretty clear. Okay, next step. And this is what's important. Here's what I want you to do. A through G, write down, put a bracket around those, and write group tests, as I've done up here. Here it says group test, page 2, A through G. Excuse me. Put a big bracket up there, A through G. Those are called the group tests. And then just beneath G, there's a little space there in that long line of stars. You can write in confirmation test and put a couple little downward arrows. Everything beneath letter G is a confirmation test. So label those. So we got group test and we got confirmation test. Here we go. We're ready to begin. You always start at the top. That's the way the lab is designed. So we start with letter A. Start at the top and work our way down. It says to 1/2 inch of original solution, right here, I'm going to add 10 drops of HCl dilute. Now I could just add the HCl dilute to this and I would get fair results. However, I just wasted 3.5 inches of original solution. And when you realize it costs you salt to mix that up, you don't want to waste it. So if it says only use 1/2 inch of original solution, simply take your next clean test tube and pour in 1/2 inch of original solution. Save this, corner pocket, you always know where it's at. Okay? 10 drops HCl dilute. Check this out, this is going to be in the kit now. Here's HCl dilute, it says HCl DIL, that's dilute. And here's where you got to be careful. When you're reaching for reagents here, be careful. Here's an HCl with a C on it. This is concentrate. You don't want to use that. These bottles, you got to be careful with. Sometimes the writing on them starts on one side and goes all the way to the other. And sometimes they start with the same letter, or 2, or 3. And you got to be very careful. Turn it all the way around so you make sure that you're getting the right reagent for the right test. Okay? I wanted HCl dilute. I got it. Double check. You take off the top, draw some up, and in goes 10 drops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, one extra. Remember, it's qualitative. Exact amounts aren't that critical. Notice I capped it and sealed it right away when you're done. Place it back in the kit so that somebody else can use it. Remember, you're sharing. Agitate, mix it up. And then make an observation. It says, if a precipitate shows, then it's in group 1. Go to number 1 below. If there's no precipitate, and by the way, PPT stands for precipitate, it says go to B, which is just beneath this. Okay? So we've got a dilemma here. How do I know if I got a precipitate? Remember from earlier in the year, a precipitate is an insoluble solid. I wrote some answers up here on the board. Do you have a precipitate? Here's what you want to go through when you're making your observations. Number 1, can you see particles? Hold it up to the light of the room, tilt it a little bit and look through the thin portion of the liquid as it's tilted. If you can see little particles up there, you got yourself a precipitate. Okay, so that is number 1. If you can see particles, you got a precipitate. Number 2, Can you see your finger? Put your finger behind the test tube and look through it. Can you see your finger clearly? If you can, you don't have a precipitate. Can you read through it? Simply take a piece of paper, even your lab itself, the write-up, and hold it in front of the test tube and read it. Can you see the letters and numbers clearly, the symbols? If you can, you don't have a precipitate. And finally, does it look cloudy or stringy? If it does, those are usually not precipitates. But there's always a but file here. Those are the ones that might be maybes. You can't say for sure that always cloudy and stringy is going to be one or the other. So in those cases, you say maybe, and you go off on one fork of the road and say, okay, I think it is, so I'm going to do this. You can always come back to that fork in the road and go the other direction and say, okay, maybe it wasn't. Let's do these tests. The clear answer on these is that you don't have to write anything down in your answer sheet based on whether you got a precipitate or not. Okay, you're going to be doing other tests. So don't panic up here. Other direction. Okay, let's pretend that I did get a precipitate right here. Okay? So what do? It says precipitate, go to group 1. So down below, I go to 1 where it says group 1, just beneath there. These are the confirmation tests. And the good news is it says precipitate may be lead chloride, which is white, mercury chloride, which is white, and silver chloride, which is white. So if I've got a white precipitate, I'm pretty happy because I've just narrowed down my answers to 1 out of 3 chances. Now, it's the time for the confirmation test. I start again at the top, 1A, and it says original solution plus K2CrO4, that's potassium chromate. Do I add it to this? No. This was original solution plus HCl dilute. This was my precipitate. So I'm going to set that aside. I don't want that. I want original solution. Do I want this? Yes, but I only need approximate amount of it. If it doesn't say the amount as this one doesn't, an inch is fine, or half an inch or so, doesn't really matter. And save the rest in the corner. Okay? It says add K2CrO4, potassium chromate, yellowish color solution. So again, it's going to go, and it doesn't say how much, so I add maybe 10 or 12 drops or a squirt. And again, agitate. Mix it up. Make your observation. Notice what there is. There's an arrow and a product. PbCrO4, and then a description, yellow precipitate. If I've got PbCrO4, it shows up as a yellow precipitate. The description is written there. Okay? In my case, I don't see a yellow precipitate, so that's a negative. I don't have Pb plus 2. Okay? I'd go on. So I set that aside and it says, okay, take your group precipitate from A.
It's not precipitate.
That's right. This is a yellow solution. That's why it turned yellow. There are no particles in there. We didn't say anything about color. We said something about precipitates. And that's a good point. I'll send around some practice ones for you. Here are 5 solutions I mixed up. Take a look at these when they come around. Go ahead and guess whether they're precipitates or not. I'll tell you at the end of the hour. Okay, so let's say this was a negative. We go back and it says, okay, go to 1B. It says group precipitate. Who was that? Is it this one? No, that's your original. It was this one. Remember, we added the HCl. This is the one that sent us to the group in the first place. So it says to that group precipitate A, add 1 inch of ammonium hydroxide concentrate. Again, I look through my kit, add the solution, and see what it does. If I get a white with salt pepper appearance of a precipitate, I've got that complex there, HgNH2Cl. I've got mercury plus 1. If from 1B it says if it's a clear solution, I got that silver complex, I've got silver, Ag plus 1. Everybody understand that? You have to be very careful to use the right solution that you're asked to, whether it's original solution, group precipitate, or something else. Okay? Now let's do a suppose. Suppose I didn't get any of those 3 to be right. What happened? We went to the wrong group. These are confirmation tests down here. If you get negative results, that means you don't have any. That means go back to where it sent you down there in the first place and continue on. You go on to group 2, and so on. Okay? So if you don't get positive results, you keep going until you do. Don't write something down unless you got a positive confirmation. Okay, any questions there? Okay, a couple of selected tests. Turn to page 3, and down at the bottom, in group 7, it says the salt may be either ammonium, sodium, or potassium. And in that 7A, it talks about litmus paper. Now, a couple things about litmus paper. If you remember, if I get one of these out of here, don't waste this stuff, and you never stick it down into the test tube to test the litmus.
Please excuse the interruption. We are caught up with arena scheduling, and we're going to go ahead and do Mrs. Bachgoven's homeroom. That's Clark through Deal. They should report to arena scheduling immediately with their materials. That's Clark through Deal, Mrs. Bachgoven's homeroom. Thank you.
Here's my litmus paper. Here's what you're going to use, the glass stirring rod. If you've got a solution you want to test, touch that to the solution, touch that to the litmus paper. One drop. And you can see you can do that about 10 or 20 times on one piece of litmus paper. That's the way you test it. Do not drop litmus paper into the test tube. That's bad. That's a rookie mistake, okay? We don't do that. Okay? And you'll test it that way. Now, in number 7, they do something a little bit different. They ask you to get a crucible or evaporating dish. You got your solution there, you're heating it up, and they're going to ask you to take a moist piece of litmus paper, which means you take distilled water and wet it down first. Distilled water won't change the color, just make it wet. And you're going to hold that over the fumes or the vapors. You're testing to see if it turns it blue. Now be careful, it says don't use the spattering. Because if you spatter something that boils up and spatters, it's going to change it to blue because of the base that's in it. You don't want that. You want to test the fumes. So that's number 1 test. Be careful on that moist litmus paper. We're trying to test for vapors and not liquid. Makes a big difference. Okay, let's do some of the other tests here. The flame test. Notice up in groups, let's see, group 5 and 7. One of the tests, the confirmation test, it says confirm with flame test. It says do original flame test. Down below it says original salt flame test. And they all refer you to page 5. So if you ever hit those, you turn to page 5 and carry out a flame test. Now, the good news is we've done these before. So I'm going to light up my burner here. Okay? One modification. If you remember back in chapter 4, we excited the electrons, jump back down, they released energy in the form of colored light. And we can identify them based on that. Same idea, only one change. Instead of using the wire flame testers and sticking it directly into the flame, we're going to use something simpler, a Q-tip. Be careful, don't touch the ends, you don't want to contaminate it. And the first thing you want to do is wet the ends with distilled water. So the end that you're going to use, just go ahead and wet it down. Because one of the reasons is, as you bring this up here, you don't want the cotton here to catch on fire. Now to test your salt, simply take your original salt in your vial, touch that wet Q-tip to some of the crystals, get some on the end, not too many. Always put the caps back on immediately so you don't have an accident. And here's what you're going to do. Instead of taking the Q-tip and placing it directly in the flame, we're just going to bring it up near the side of it, the edge of it, and watch what happens. Everybody see it? Everybody see it? Again, it's that initial burst of color. Sometimes it helps if you hold something white behind it. You can actually see this a little bit better. Everybody see it? That's the way we do the salt flame test. Okay? Robert, if you know what this one is, this is your first cation, go ahead and record it correctly up there as soon as you figure out which ion you have. Yes. distilled water. Okay, if you notice there in the flame test procedure, it lists 4 different colors, 4 different ions. If you saw beautiful crimson red, you know it is strontium. You would record in the upper left-hand corner, capital S, little r, +2. Looks like Robert's got it right. He's got 50 out of 50. He's on his way. Any questions? Next test. Let's try the borax bead test. And if you're looking for a referral here, on page 3, up in group 4 and 3 and 4. That's actually just group 4. Just group 4 referred you to what's called the bead test. So you turn to page 5 again, and up at the top it says borax bead test. Here we go. If it tells you to do it, this is what you're going to do. First thing is, get a Fisher burner. You're going to have to share these. These will be out in the center table. We don't have enough for everybody. You got to share. So we're going to turn that on. A little bit hotter flame than the other. That's why we use it. We also need a couple other things ready. You're going to get some borax. Okay, it's going to be well labeled to be in the center. Borax. And a crystal or 2 of your unknown salt on a watch glass. Okay? Here's what I need. I need a piece of glass tubing. This is glass tubing. This is our stirring rod. This came out of my drawer. This came out of the center table, and I'll have a big beaker of these. Do not use your glass stirring rod for this test. This is special glass. It's rounded at the ends, and it's shorter. Use that for stirring and other things. Do not use it to stick in the flame and do this test. That's what these are for. Okay? So, I'm ready to start. Now, the only problem is I need a clean end. And both ends of this one have been used. Don't panic. We're going to cut off an end. Use our triangular file. Here's what I'm going to do. I'm going to set it down on the desk or the table, and about 1.5 inches from the end, I'm simply going to draw across the glass 1 scratch. Listen. And that's it. I do not need to saw it back and forth, grind through it, and have glass crystals go all over the place. 1 scratch, and here's what you do. Turn the scratch away from you, put your 2 thumbs behind the scratch, and snap. It breaks easily. Throw the little piece away, and I've got a clean end to start with. Okay? I'm ready to begin. Here we go. How many people have ever seen glass blowers? What do they do with the glass as it's in the flame?
Turn it.
They turn it. Notice I'm holding it with one hand and turning it with the other. I'm getting the end red hot. You can see. By the way, this is a good color for one of our ions. What color is that? Bright yellow orange. That's sodium. That's sodium. That's a good coloration for sodium. So you might make that note. You've seen it before. Yes. Okay, here we go. We got it nice and hot. It's red hot. I've got my borax ready, and watch what I'm going to do with this red hot glass rod. I'm just going to stick it right in the borax. You'll hear it sizzle, and it will stick to it. Oops, got right off there, didn't it? Okay, goes back into the burner. Continue to turn it. Now what I'm trying to create here is a little bead on the end of the glass rod. The bead should be clear, and it should be rounded. Notice I'm continuing to turn it. Heat it up for another 30 seconds or so, and then you're ready to check it out. Mine looks good, a nice bead. What I want to do is take that red hot bead and touch it to a little crystal of your salt, and again, it's going to sizzle and melt. Okay? And this is one area where you don't want to use too much, especially on the manganese. One little crystal is enough. You can always add more later, but you can't back off on using too much. Back into the flame. We're going to heat it up red hot again. And what we want to end up with, if it's a positive test, is a tint that's literally within this glass bead. And I'll bring it around so you can see it, assuming we get a good result. And Adam, this is going to be your second cation. So when you think you know what this is, you can check yours. Write it on the board. Okay, I think it's ready. And one thing I want to do is not look at it and judge it until it cools, because it's a different color when it's hot. Good news, we have a base or a standard to compare to. When you're doing this borax bead test, it's one of two things. Manganese, which will come out this reddish-brownish color, and cobalt, this pretty blue color. Those are your only two choices. So when yours cools, you're ready to match it up. And I'll bring this around so you can see it. Take a wild guess at what I got. Don't say anything, because Adam's got to figure it out.
Yeah, go write it by your name.
See which one it is? Pretty obvious.
Just sit down, dude.
I'm not kidding. Sit down.
Okay, those of you that saw it, should have been obvious. It's a pretty blue color. It seems like it's within the glass itself. It's part of the borax bead. It is obviously cobalt. If Adam wrote this correctly up in the second column, his second cation, and he put capital C little o and a +2 in the upper left-hand corner, it looks like it is correct. Okay, so he would get 50 out of 50, and we move on. Any questions? One more test. This is one you're going to love. Turn to page 3 again. Again, a referral. This comes out of Group 3 and Group 4. Groups 3 and 4. If it refers you to something called the cobalt nitrate test, that's the test I want to show you right now. And it says, go to page 6, this is the one on the back side. We need to go back to the regular burner. Turn this off. We'll go to the regular burner. And watch carefully, because this one is kind of a tricky one. It's a great test, but it's kind of tricky. One thing you want to do is turn down the gas a little bit. Don't want to have a huge flame here. Okay. Now it's called the cobalt nitrate test, and you're going to need a couple specialized things. One is a charcoal block. Very soft. You know what charcoal is. We got a clean end here. So what I want to do here is take my scupula or spatula and just make a little indentation in the end of this. You can see it's kind of soft. It's easy to make just an indentation. Not a hole, but just a little indentation. Okay? We also need something else. A blowpipe. This you want to wash with soap and water before you use it. Okay? Now, what goes in the indentation is your unknown salt. So whatever one you're testing for, I've got my unknown right here. And I'm going to take just a crystal or two and place it in that indentation that I just made in the block of charcoal. Okay, always cover that back up with the lid. And I'm going to do one more thing. I'm going to add a drop of distilled water to that crystal. And this thing doesn't make drops very well, so I'm going to practice first. Whoops. There it goes. You got to be careful. Sometimes you get too much. I got quite a bit of water there. That's okay. I'm not going to panic. I am going to keep an eye on it, though, because when this evaporates, it may go off to the side or the end or the other side. Watch where it goes. You want to keep track of the residue. Now, the blowpipe. It's made out of metal. One thing you do not want to do is stick it into the flame. You're going to see I'm going to bring this up next to the flame. I'm going to blow through it, and it's going to create like a little blowtorch out the other end. First thing I want to do is hold the charcoal block flat and first evaporate the water. Once that occurs, I'll stop and show you, and then I'll be able to turn this charcoal block up sideways and get it red hot. Okay, there it goes. You may have seen the little drop which sort of went down the side. That's okay. Right now, all I've done is evaporated. Now I want to get that area red hot. Okay, so take another breath. And get it red hot for a few more seconds. Okay? Next step, we're not quite done. Now comes the cobalt nitrate. It's a lovely pink solution. This will be out on the center table. It's not in your kits. You want to take a drop of that or two and place it in the indention and any place that residue went. So I'm going to add one drop here right to that edge. Okay? And again, we're going to reheat it until it's red hot in the flame. That should be good enough. We're going to let that cool a little bit. Again, you want to judge things when they cool down, not when they're still hot. I'll start to bring this around. You should be able to see the coloration. And Tony can take a real close look to see what color this is going to be. It'll actually get to be a little bit better color if I let it wait, cool down a little bit. I've been working down here on this end. You can see where the residue went. Tony, if you think you know what it is, you can record that up on the board. Okay? Now, Tony, if you wrote down capital Z, little n with a +2, it's obviously zinc. The other color that could have been on this test is a lovely powder blue. That would be aluminum. So you're only testing for two different ions. It's either zinc or aluminum. If this was your second cation, you'd get it right. If it was your third, you'd miss it. But I didn't tell you, so we'll give it to you. Okay? Z is +2. Any questions about recording scores? Couple more comments here. What if you do that test I just did, the cobalt nitrate, and you get nasty looking mess on the end of the charcoal block? What does it tell you?
Probably did the wrong test.
And it tells you one of two things. One, you did the test wrong. You can always repeat it. Two, if it's a negative test, you did it correctly, you don't have zinc, you don't have aluminum. And it's just as good though. It's a negative test. You didn't win any points there, but you didn't lose any either. Now you know it's not one of those two. You can go off and do something else that you're supposed to be doing. Okay? So look at the negative test with a positive view that a negative is good as a positive if you can turn around and know that you don't have those things. Same thing with the bead test. I've seen lots of these bead tests, and when you go to pick up the glass rod, you'll see lots of negative tests. They'll just be this big black glob out here on the end. They either did one of two things, used too much of the crystal salt, or They're using an ion that shouldn't be used for this test. So again, a negative can be just as good as a positive. The negative won't show up on the chart. These are only positive. He says, what's a negative test look like on the cobalt nitrate, the charcoal block? You won't see a green tint. You won't see a blue tint. Neither one of those will you see. That's a negative test. No, those are the only two you can get, green and blue.
You just had it so fast.
Oh, this? Oh, yeah. Yeah, there'll be lots of charcoal blocks out here, and yeah, all you need is one clean face. So this one looks like we've used it, maybe there's a chance we can use it here, but also on the other end, looks like we could use that one, and that's it. But yeah, then we can cut this off and use some more. So you can use every face that's on here, so you can get at least 8, 10 to 12 uses out of it. Okay? Any questions? Okay, one final note. Things I can't stress enough on both the group test and the confirmation test. Remember, it's designed so that you start at the top and work your way down. Never start in the middle and go either direction. That'll get you in trouble. Don't guess until you have a positive confirmation test. That avoids a lot of misery. Don't write it down until you get positive confirmation. Everybody understand that? People that give up. Any questions?
Well, if we come up and ask if you think it's a precipitate or not, will you tell us?
Okay, good question. Help. Here's what I will and will not do. I will not make a decision for you. I will not tell you whether you have a precipitate. I will not tell you what color it is. I will not tell you to go down this road. That's your decision. Things I will help you with, if you ask me about precipitate, I'm going to point you to those 4 things up on the board. You make your decision based on that. And remember, something like a precipitate, again, it's a fork in the road, either it's yes or no. If you try the yes and it doesn't work, you can always come back and try the no way. You do not have to write anything down based on that decision. You want confirmation test, right? The other thing is, if you have questions about these tests that you saw today, I refer you to 2 things. One, they're in the write-ups. So if you were watching me today and not reading, it's possible to go back now and just read how to do both, or all the tests that you saw today, okay? So refer to those. If for some reason you need some help doing a test, if you want to make sure you're doing it right, you can come see me. I'll help you with the technique. But again, I won't give you answers as to what should be decided and so on. Any other questions? Tomorrow is day 1. Your key doors will be open. Remember, you got test tubes out on the outside that we share. You can use the test tubes in your drawer, and you may keep those in there. But remember to leave the ones outside where they are. Remember, goggles will be cleaned between classes. They'll be ready. Aprons must be worn as well. And remember, up front will be your report sheet, your scoring sheet. That's where you record answers. Give you a word of caution at the end of the first day. If you don't have one, don't panic. At the end of the second day, then you can start to worry if you don't have one yet. Okay?
Yeah.
But normal time allotment is 4 days for the cations and 2 days for the anions. The anions are much shorter, so don't panic.